Okay, this is a prototype that I need to develop the last indexing system I'm going to put onto this lathe. I've already got three, and they've all got shortcomings, and I've ended up with loads of index plates for all different things. So I want a digital indexing that does everything. So what I've got here is, this is like a little wood turned box effectively, and recessed right in the bottom of it is an AS5600 rotary encoder. And what that does is, with a magnet in the lid, there's a mortise that fits inside a bearing, and that bearing fits exactly inside that box, and that's why that's sunk down inside the box. And in the middle of this mortise there's a tiny magnet which has got north-south going across, and as that turns around that little sensor in the middle of the rotary encoder, that detects the angle very accurately. It divides 360 degrees into 2048 divisions. That might mean nothing, but if I had a 10-inch index wheel, that could divide it into less than half a millimetre divisions. So extremely accurate, for more than accurate enough for wood turning for sure. Okay, I've got an Arduino, a breadboard which I haven't used yet, and an LCD. So if I just pop that back in, it's going to change my position, but I'm going to put it in that way round. There we go. So now that magnet's right above the rotary encoder, and the bearing means it's turning true about the centre of that rotary encoder, the sensor. Okay, so let's give it some power. This is just a power bank. And I'm going to zoom into the screen if I can. I can't get it all on at once, I'm sorry, but can we see the screen yet? That's as tight as we can get. Bear with me, I'm on a lower. Probably be a lot of dust come down off here because I've been turning a lot lately. Lower this arm down so we can get right down to that. So we can see the screen, I hope. Go a bit further, because the camera's completely zoomed in at the moment. That should do. Hopefully we can see that. The light's not going to blare it. Ah, now we can see. Right. Got too much light on it. So now, as I turn that encoder, the little lid of the box, if you like, you can see that it's changing. So let's find 0. And with this box I made being small, it's like 65mm. The amount of turning that you have to do is tiny to get. There's 59.9. I can't quite get 60 because I can't turn that lid small enough an angle with my fingers, you know, to do it. But let's get 180 degrees. There's 180. Anyway, this isn't the point. The point is this. Oh, I could have gone tighter. So there you go. I don't know if we can see that on the screen, but right, what in reality that's going to be is that encoder. I'm going to extend my bedways out behind the headstock spindles here. I'm going to extend my bedways out with the I've got a bedway extension, and I cut one end off to extend the tailstock end of my lathe so I could get my tailstock out of the lathe, out the way when I'm turning. And then the other bit of it I'm going to chop up to make an extension to my bedways behind the headstock. I'm going to switch this off, and that encoder is going to be on a post in the middle of that bedway, so that it comes exactly central to the what's it called, the wheel that I'm turning the spindle with now, the hand wheel. That's it. So I'm going to fix something possibly on the hand wheel, probably on the hand wheel actually, not sure yet, with that rotary, with the magnet inside it. So that magnet here will be inside my spindle, and then the rotary encoder will be on a post, the sensor will be on a post coming off that bedway extension that holds it on centre. So everything will be working on my spindle centre, and the position that I'm reading on this Arduino on sensor is exactly my spindle's rotation, and I'll be able to set zeros and set division increments, you know, set say by angle or by number of increments or whatever I want really, and also set offsets, so that I can set a zero anywhere on the turning and then do the indexing from that point. There'll also be a stepper motor, and I'll find some way of fixing a largish pulley, big as I can afford, a timing belt pulley. On the stepper motor a small one, on the spindle a larger one, so that I get more accuracy out of a stepper motor. And what will happen is that the stepper motor will turn the spindle to where it thinks it needs to be, but this sensor will then give feedback and turn the stepper motor to exactly where it needs to be, to within less than 5/100ths of a degree is what I'm expecting the resolution of this to be. So more than accurate enough. Obviously I've got a lot of work to do on this, because I've got to make that bedway extension, make the post to hold the encoder, source a stepper motor. I may have a motor driver for the stepper motor, I may not, so I may have to source another motor driver. And the other thing is I want a joystick to do all of the controls by a joystick, so I'm working on a menu system on a separate project, so I can have it, the main mode will be in indexing mode, where moving the joystick left and right will just toggle it backwards or forwards one increment. Up and down will change the menu, so that I could change the number of divisions, for example, or set a custom division, or set an offset. So that's a separate project. So this is what I'm saying, is this is going to take a while, because there's quite a lot of development, and also that metal working, which I'm not going to do in the cold. I'm going to wait for it to warm up a bit before I even think about handling cold metal. So that's it really. It's I've finally broke the ice on this project, which I've been meaning to do for over a year. And my main concern was finding out which sensor would work to give me enough accuracy to make this worthwhile, and it's an AS 5600 sensor rotary encoder. It's lovely. So there we go. Thanks for watching, and I'll do periodic videos about this as I make some decent progress, and then I'll do a video covering everything when everything's done. Thanks for watching.